Hello, and welcome to the world of metals. Now, you may be wondering, why is he holding an axe? That's a great question. And today I'm going to answer that because I'm talking, as I said, about metals. Specifically a metal called CPM3B, made through the Crucible particle metallurgy process. This process, from a company known as Crucible, is superior to the traditional wrought metal manufacturing process in that it gives the metal an isotropic grain, which essentially means that instead of having a continuous grain direction, which makes it easier, similar to how wood, when it's chopped with an axe, like this, similar to how it breaks in half along the grain direction. And that's what happens if you have a continuous direction. Again, it depends on the metal, but with powdered metal, it looks similar to this. Here's traditional wrought metal, then isotropic grain. It really doesn't have a grain direction, so it makes it just as strong in any part of the blade, which makes it unique. Also, two other things. If you were looking for the perfect metal, or the perfect tool, what would you want in it? You'd probably think extreme strength. However, if you have too much strength, this is what happens. That broke. This was too brittle. It's a Rockwell of 64. Now that could be a good thing, but you have to have a balance of strength and plasticity. Plasticity is how much pressure an object can withstand before it bends, or how far it can bend before it breaks under pressure. Strength is pretty self-explanatory, how much pressure an object can take before it either starts to bend or snaps. CPM3B is commonly used to make smaller objects, such as tools, as opposed to structures such as bridges and skyscrapers. How it's made is it's put in a mold. First off, powder is put in a mold. This is one way. Then it's pressed. That's at a reasonably high temperature, taken out of the mold and sintered afterward. Otherwise, if it weren't sintered, you could still break it. Now, compared to, again, traditional wrought product, this is D2 steel, tool steel, which is fairly compact. CPM3B is almost 100% compact. You can't get much better than that. What can you get, 110%? CPM3B, compared to D2 or other commonly used metals, especially expensive metals, has better wear resistance, shock resistance, toughness, pretty much the same thing, compression strength or hardness and hardenability, machinability, grindability, and stability. That makes for a terrific combination. Powdered metals are the future of metallurgy. If you want to learn more, you can go to Crucible's website, crucible.com, and I hope you learned a lot and have a great day.